Okay, the problem went something like this. The area inside a rectangular fence is 1,800 square feet. Okay, the fencing along 3 of the sides were $6 a foot, and the cost of the 4th side was $18 a foot. Okay, we want to find the dimensions of the rectangle that will allow the most economical fence to be built. Okay, the wording of the problem was something like that. Okay, so what we want to do, first thing I would always do when I do a max min problem is to draw a picture of the shape. So I'm going to draw a rectangle and label the length and the width. I'm just going to let x be one side and y be the other. Doesn't really matter which is length and which is width right now. Okay, and I want to think about what they have given us and what we're trying to do. Okay, so what they're giving us is that the area is 1,800 square feet. Okay, and what they're asking us for are the dimensions that will make it the most economical. Okay, so if it's the most economical, it's going to be the cheapest. Okay, so we want the cost that's going to be the cheapest. Okay, we want the cost to be at its minimum. So I want to focus on getting a formula, an equation that represents the cost. Okay, so the cost equals, okay, now we need to think about well, they tell us about the cost. Okay, 3 sides are $6 per foot. Okay, so I'm just going to take 3 sides and make them $6 for every foot. Okay, so I'm just going to let this side on the left be $6 a foot. So the cost of it would be 6 times x. Okay, $6 times the number of x feet. Okay, the cost of this side would be $6 times x feet. I'm just going to let the top side be $6 per foot for y feet. And then the last side, I chose this bottom just to be the last one. It's going to be $18 per foot. So $18 times y. Okay, so I need a cost equation that represents the total cost. So I'm just going to write the cost equals, I'm just going to add these up. 6x plus 6x plus 6y plus 18y. Okay, I'm going to get my like terms together. Okay, 6x plus 6x is 12x. 6y plus 18y is 24y. Okay, so there's our cost function. Okay, the only problem with this, I mean, it's correct, but we can't find the derivative or anything. We really don't want to have an x and a y. Okay, we don't want to have an x and a y in this cost equation. But look what we can do. We know the area is 1,800. So I know that the length x times the width y, okay, and again, it doesn't matter which is which, x times y equals 1,800. So since they're giving me this fact, okay, I can solve this equation for one of the variables and plug whatever we get into this equation. So I'm just going to solve this equation for y. I'm going to divide each side by x. So y has to equal 1,800 over x. So I'm going to take this cost equation, and where I see a y, I'm going to replace it with 1,800 over x. Okay, I'm going to go ahead and simplify. Okay, 12x. Okay, 24 times 1,800. I'm going to use my calculator. 24 times 1800 is 43,200. Then I have an x in the denominator. Okay, now you said that you can use a graphing calculator, okay, for this, for everything on your test, right? Okay, now you can actually find the answer to this problem just by looking at this cost equation graphed. Okay, I'll go ahead and show you in the video. If you want to keep going, you can. How to find it without. I can't imagine how you couldn't. Maybe the graphing calculator would be hard to see. Okay, but I can graph 12x plus 43,200 over x. Okay, that's going to be my cost equation. Okay, so I could go to a graphing calculator. I like Desmos. I could graph that equation, and I could figure out where this cost is the cheapest, where it's the minimum. Okay, so I could just find the minimum, and I can tell by my graph that x is 60. But again, maybe your graph, you couldn't really tell for whatever reason what that minimum value is. See, it's showing that the cost is decreasing until you get to 60. Then it's at the lowest the cost will ever be. Okay, then it increases from there. Okay, so the minimum cost would happen at x equals 60. Okay, so I could say x, the minimum happens at x equals 60. Okay, that would be 60 feet. Okay, y, we can find y because we have here that y is equal to 1800 over x. We can just figure out what that is by going back into that equation. So y is 1800 over x, or 1800 over 60. Okay, so y has to be 30 feet. Okay, these are the dimensions that will give you the cheapest cost. Okay, 30 feet and 60 feet. Okay, real quickly, I'll show you if you didn't have a graphing calculator or if you just want to know how to solve this another way. Okay, if this is the cost, go ahead and end the video if you uh, have what you need. But if this is the cost, and I want to know when the cost is at its minimum, I could figure out where the derivative is 0. Okay, because the derivative of 0 is going to be at a minimum or a maximum point. So I could find the derivative of this and figure out where it's 0. But before I do that, I would rewrite it. I would rewrite this as 12x plus 43,200 x to the negative 1. Okay, then I would find c prime. Okay, the derivative. Okay, the derivative of 12x is 12. Okay, the derivative here, I'm going to take negative 1 times 43,200. Okay, that's negative 43,200. Okay, subtract 1 from negative 1 gives me negative 2. I'm going to rewrite it by putting x to the negative 2, writing x squared on the bottom. Okay, there's my derivative. 12 minus 43,200 over x squared. Okay, so the minimum, okay, or maximum, if it was that kind of problem, is going to happen where the derivative is equal to 0. Okay, so I know that the minimum has to happen when that derivative is equal to 0. So I could solve this to get the 60 if I had to. Okay, if I wanted to solve this, if it was me, I would add the 43,200 over x squared to both sides to get rid of it. I'm running out of room here. So if I added that to the other side, I'd have 12 on the left and 43,200 over x squared on the right. Okay, so to solve this, different ways to do this, but I used to tell my kids, if I have an x in the denominator, which is kind of funky, I would make one side into a fraction, so they're both fractions. So I have 12 over 1 equals 43,200 over x squared. Okay, then I would just cross multiply. Okay, 12 times x squared, which is 12x squared, equals 43,200 times 1. Okay, so that's 43,200. Okay, I can divide each side by 12. I get x squared equals 3,600. Okay, I can then square root that to solve for x. And I get my x value to be 60. So that is the other way to figure out where the relative minimum is. Okay, it has to happen at x equals 60. Okay, Joseph, I hope this helps. Sorry, I didn't know what to do when we tutored, but I think at least hopefully if you had this kind of problem on a test, this may help a little bit. Okay, let me know if you have questions. You can email me if you have any questions at all.